Nuclear energy. Nuclear energy is the energy held in the nucleus of an atom. It can be obtained by two types of reactions, fission and fusion. Nuclear fission produces energy through the splitting of atoms, which releases heat energy that can be harnessed to produce electricity. The fuel most commonly used for nuclear fission is uranium. However, other elements such as plutonium and thorium can also be used. All of today's operating nuclear plants use nuclear fission to generate electricity. The second type of nuclear energy is nuclear fusion, the same process that powers our sun. Fusion is a nuclear reaction in which atomic nuclei collide at a high speed and join to form a new type of atomic nucleus. During this process, matter is not conserved because some of the matter of the fusing nuclei is converted to photons, which produces energy. Fusion power offers the prospect of an almost inexhaustible source of energy. However, creating the conditions for nuclear fusion presents a potentially insurmountable scientific and engineering challenge. A recent experiment has shown that nuclear fusion can be achieved. However, it has not yet been successfully demonstrated on a commercial scale. Today, nuclear power plants account for 11% of global electricity generation, with about 80% of that installed capacity being in OECD countries. All of this capacity is nuclear fission. Nuclear energy, through fission, can release 1 million times more energy per atom than fossil fuels. Nuclear plants have large power generating capacity and low operating costs, making it ideal for baseload generation. Because of its large scale and centralized nature, it can easily be integrated into electricity grids, requiring few changes to existing infrastructure. However, upfront capital costs are intensive and present financial risks to investors given the long time frames power plants must operate to recover these costs. Nuclear energy does not emit greenhouse gas emissions. For this reason, it is often seen as a substitute for fossil fuel electricity and a solution for mitigating climate change. However, nuclear power holds a wide variety of environmental and health issues. The largest concern is the generation of radioactive wastes such as uranium mill tailings, spent reactor fuel, and other radioactive wastes. Some of these materials can remain radioactive and hazardous to human health and the environment for thousands of years. Several nuclear accidents in recent history have negatively impacted the environment and surrounding communities, making nuclear power a controversial topic for the general public. That's nuclear energy.